This summer, I used a cloud-resolving model to study the life cycle and net radiative effect of tropical anvil clouds. Atmospheric scientists who study the global climate make predictions about how the climate will change using global climate models, or GCMs. These models take into account several complex Earth and atmospheric processes and try to model how these processes interact with each other and how they change in time. Clouds are a major source of uncertainty in GCMs because variables which affect cloud properties interact in complex ways which require small spatial and temporal scales to model accurately. Since computational power is limited, variables which cannot be solved for explicitly are parameterized based on our best observations and knowledge about cloud processes. Cloud-resolving models use smaller grid sizes and a smaller domain than GCMs in an attempt to resolve more cloud processes explicitly within a reasonable computational budget. Cloud radiative effect is the difference between the average and cloudless energy balance. Initially, anvil clouds seem unimportant to the Earth's global energy balance since they tend to have a near-neutral net cloud radiative effect. Upon closer inspection, we see that the initial deep convection that characterizes anvil clouds contributes to a cooling effect, since reflected shortwave is larger than emitted longwave at this initial phase. The subsequent thin cirrus clouds contribute to a large positive longwave cloud radiative effect, and the combination of this longwave and shortwave effect gives rise to a near-neutral net cloud radiative effect. Is there a feedback mechanism in the physical system causing a trend towards net neutral CRE? If so, what physical mechanisms cause this trend, and could those mechanisms change in changed climate? Or is the cancellation a coincidence, in which case could changing atmospheric conditions change anvil cloud properties and give rise to either a strongly positive or strongly negative cloud radiative effect? If the way in which anvil clouds contribute to the Earth's global energy balance were to change, this could have large impacts on the rate of Earth's warming. Thus, we wish to understand the internal dynamics and physical mechanisms of tropical anvil clouds, what affects anvil cloud structure and amount, and how well these dynamics are simulated in global climate models and in cloud-resolving models. So my question for the summer was to study how changing horizontal and vertical grid spacing affects the relevant cloud properties in simulated anvil clouds.